Hello everyone, this is Unit 4, Part 1 notes on atmosphere. Our objective is EEN 2.51. We will summarize information from charts, graphs regarding layers of the atmosphere, temperature, chemical composition, and interaction with radiant energy. The purpose is to make sure you understand the composition of the atmosphere, understand all the layers of the atmosphere, and how the sun and earth interact and have a relationship. One of the things I want you to see is the atmospheric composition. The atmospheric composition mostly consists of nitrogen and oxygen and argon, but nitrogen and oxygen, 78% nitrogen, 21% oxygen. Okay, so that is what it mostly consists of, our atmosphere. As you see, I have these things in red for you, as well as I have the annotation pen to help you direct what is important about these notes. So again, the composition of the atmosphere. The most abundant thing is nitrogen. The second most abundant is oxygen. Okay, a lot of people say oxygen is first. It's not. It's going to be nitrogen. So that's first, and that is second. Together, they make up 99% of the clean, dry air. Now, yes, carbon dioxide is important, but it's important for absorbing energy in the atmosphere, okay? For the absorbing of energy. Now, water vapor is the source of all the clouds. So that's in all the precipitation. And it also absorbs heat given off by the earth. So the water vapor actually kind of cools it down a little bit. The ozone. The ozone is a form of oxygen, which is basically three oxygen atoms bonded together instead of there were just two. We breathing O2, but inside the ozone it's known as O3. Okay? Results from oxygen absorbing radiation energy from the sun. The ozone layer is crucial for life on Earth because it absorbs the harmful radiation. So we need the ozone layer. That is important. Why is it important? It absorbs the harmful radiation. The ozone layer is also important because it allows us to live here on Earth. Everything exists because of the ozone layer. So we're going to go into the thermodynamics of the atmospheric layers. So as you see here, there's a chart right here. And the question I propose to you is, why does the temperature change from one layer to the next? So here's the temperature at the bottom. And you see that the temperature here changes as we get higher in the layers of atmosphere. So why does it change? Well, hopefully these next couple slides will help answer that question for you. All right, so here the first layer is going to be the troposphere, closest to Earth, okay, right here. I know you really can't see it that well. Contains the mass of the atmosphere, most of the mass. But this is one key point right here. Weather occurs here, pollution occurs here. The upper limit right here is called the tropopause. Tropopause. That is the upper limit. This is the level right above the troposphere. This is where a gradual decrease in the temperature stops. So now this kind of starts giving you the answer why it fluctuates. So that's a stop. Once it stops, it has to do what again? Change up. Okay. Stratosphere. Now, this is the level, again, right above, boom, the troposphere. This is mostly ozone. So this is where all the UV radiation and stuff is absorbed here. The layer that's right above that is called the stratopause. And again, that's where it pauses, so it'll go like this. So we have to stop it, and then that's how it has to gradually go back up in temperature again. The mesosphere. So mesosphere is right above the stratosphere. Okay? And meso basically means middle. If you see here, it's just like your little middle area, because there is one more layer, and it's called the exosphere. That is not mentioned on this, which would technically be this outside area. But right here, there's no concentrated ozone here. So temperature drops again. And then there's a pause. That's the upper limit called the mesopause. This mesopause is again when temperature stops. So this is why we have thermodynamics inside the atmosphere layers, and it pretty much goes with what I just drawn on the screen. Thermosphere. This one is above the mesosphere. So of course, here this contains a small part of the atmosphere's mass. And here the temperatures and this can get greater than 1,000 degrees Celsius. So the ionosphere. The ionosphere is the thermosphere, can be identified in two parts, and the ionosphere and then the exosphere. Sometimes we don't really talk about the ionosphere as much, but we do talk about the exosphere. It contains many ions and free electrons. So ionosphere, ion. Okay. Auroras. These are these nice lights. So sometimes I think they call them like the northern lights or whatever. These occur in the ionosphere. So this is a beautiful display, as you see in the picture. I would love to see this personally. But what happens is it's the interactions between particles from the sun atmosphere and the gases in the ionosphere. So the exosphere, we're finally here. This is the outermost layer of the atmosphere. Light gases like helium and hydrogen are found here, but above the exosphere is called outer space. Okay, so we have to get there to get out of space. Okay, get in the space. No clear boundaries though, so it's just kind of there. We have different ways that we have atmospheric energy. The sun is a source of energy for everything, right? That is the sun energy, and I hate how I just wrote that. But there's three ways energy can transfer: radiation, conduction, and convection. Radiation. Here is the sun. Boom. Here is the radiation, and that's come from visible light, what we see. UV is what we be protected by from the ozone layer, and then of course other electromagnetic waves, which we have talked about before. And this picture right here pretty much can show you the percentage of where we get some of the energy from. Conduction. You see this pot right here in this picture. It's being heated. Okay, conduction is the transfer of heat energy that occurs when the particles collide. So this is the surface transfers energy through nearby air particles. And this happens usually in the troposphere. So energy in the nearby, and it transfers energy. So conduction is here. The reason why it's feeling here is because the heat is coming here and then it kind of transfers there. So conduction only affects small layer of the atmosphere though, just a small portion. But convection is when it's transferred heat energy by the flow of the heated substance. So pockets in the air near Earth's surface are heated, becomes less dense. So in other words, keynote, as warm air rises, it expands and starts to cool. And it cools because the density increases, okay, and the cooler air sinks. So this is why you got go up, and see, convection comes back down. So it comes down again. So as the warm air is rising, it has to expand. And so this is why as it cools, it's because of the density and stuff increases. These are just definitions. Temperature and heat. Temperature, measurement of energy. So, and then heat is a transfer of energy. Okay, temperature is basically measuring the energy or the heat. Pressure and density. Air pressure increases towards the Earth's surface. So increases towards the Earth's surface. Atmosphere decreases with height. So the pressure, have you been on an airplane? And the higher you get on the airplane, what happens to your ears? Come on, what happens to your ears? They pop. Okay. When they pop is because of the atmosphere pressure has changed. And so there's fewer gas particles above you, so all that air and the extra contents are there, and so your ears pop because the pressure. So this again, as the atmosphere decreases with height, so the higher you go on a little airplane, let me draw a little airplane right here. The higher you get up, and it's an ugly airplane, in an airplane, so the higher the airplane goes, the atmosphere pressure drops. Okay? So as you see here, temperature, pressure, density, and it increases. So as temperature increases, pressure increases. As temperature decreases, pressure decreases. As temperature decreases, the density increases. And as temperature increases, the density decreases. So atmospheric pressure and density and dynamics, these are just questions just to ask you. What happens to pressure and density as you go higher in the atmosphere? I already answered it, so this is up to you. So I want you to think about that. And I will use this question on an assessment. Why do changes in pressure and density occur? Alright, so temperature inversion, a condition in which cold air underlies warmer air that is higher at altitude. Okay? Inversion. This occurs when the air near the ground rapidly loses its heat on the clear night. Key point there for you. So basically in this situation, the ground gets cold quickly while the air above it kind of has heat again during the day. You can walk on grass and stuff and the ground is usually cool, but it's just like you walk on the tar and it's hot because it's a different type of material. But that's also because, again, this situation right here, the air near the ground rapidly loses its heat on a clear night, but it can still be humid around you. So the best way to show you this is normal condition is warm air goes into the cold air, and then temperature inversion, you see how we got different smog and just a little bit of things here, and then the cold air now instead of going it comes back down. Right here we didn't have just the cold here at the bottom, but in this type of inversion you see that cold air, it was warm air then cold air, right? Inversion means you switch it, so it's cold air then warm air. So we have to understand about the moisture in the atmosphere. This will not take long. Again, everything is highlighted in red for you to help you understand. But water vapor is the most important gas for the understanding of the atmosphere processes. So water vapor makes up to 4% of atmospheric gases. This has to be known as saturated. Warm saturated air comes from more water vapor. Now this is a key thing because I'm going to give you the definition in a minute. Relative humidity is the ratio of air water vapor content capacity to hold water vapor at the same temperature. So the ratio of the water vapor is the same as the capacity at the same temperature. So what are the three forms? Y'all know it. Solid, liquid, gas, right? Solid, snow and ice. Rain, water is liquid. Clouds, water vapor. But how do these water influence weather? Because that is going to be our next one, is going to be weather. So basically, atmospheric process, water vapor is the most important gas. And we know that it's important because, again, it helps cool, right? So because we already know it holds from 4 up to 4%, when have you pretty much felt it at 4%? This is a question for you. All right, so what about 0%? You still don't know? Well, it's because water vapor is the humidity that you feel in the air. We have went outside some days and it be humid and it feel like you can't breathe. So now you got to see where the water vapor is and what level of humidity that would be and what percentage it would be in. So you actually know if it's really humid because of the water vapor percentage. So we talked about the word saturated earlier. So what does it really mean? Well, air that has reached its water vapor capacity is be saturated. So if you reach what you're supposed to be, I say I'm satisfied. right? So saturated. And if I'm saturated, I'm satisfied. So warm, saturated air contains more water vapor than cold air. Okay, more than cold air. Why? Because warm air can hold more water vapor. Is answer this question. Okay, when you have noticed the humidity more in the summer or in the winter, it's because warm air can hold more water vapor. Relative humidity is the ratio of air's water vapor content to its capacity to hold water vapor at the same temperature. Relative humidity indicates how near the air is to saturation, not the actual quantity of air water vapor though. But relative humidity, these are your key points. Varies with temperature. Okay, we know that. Cooling air increases its relative humidity and warming air decreases. So please know these. So if I ask you on your next assessment, please know some of these things are going to be direct quotes. And as well as I finish this presentation, please know our next lesson is going to be on clouds, and as well as some areas of weather. I'm going to break down the different layers of clouds for you. And if you have any questions, please email me. And I thought that was the last slide. But this one. Why does lowering the air temperatures cause relative humidity to increase? Because colder air cannot hold as much water vapor. Why does increasing air temperature causes relative humidity decrease? Because warm air can hold more water vapor. More water vapor is basically known to be more saturated.